So children, exercise 2B I wanted to discuss with you all. So there are some questions that you need to do in your fair copy that I will be sending you. You have to do yourself, okay? I'll tell you which questions you have to do. Then numericals, some of them I have solved for you, but some I wanted to discuss because these are very simple questions and you need to learn how to observe the graphs, okay? So let us see question number 6. Figure 2.40 ahead represents the displacement time sketch of motion of two cars A and B. Find the distance by which the car B was initially ahead of car A. So let's see the graph. This is the graph. Okay, you have to find out the distance by which the car B was initially ahead of car A. So initially, that means at this point, what was the displacement of car A? 0. And the displacement of car B? 40. That means car B was 40 kilometers ahead of car A, right? See the answer, 40 kilometer. Then second one, the velocities of car A and car B. What were the velocities of car A and car B? So how do you calculate the velocity from a displacement time graph? By calculating the slope. So you have to find out the slope of this line and slope of this line. Let us first find out the slope of car A. So slope means this upon this. So 1 upon 1. Okay. That means the velocity of car A just a minute. Yes, okay. So this was the graph of car A. Okay. So this point. Okay. So this represents 40. Can you see here? This represents 40. So 40 upon 1. Sorry, somehow I said 1 upon 1. I'm sorry for that. So 40 upon 1. So 40 kilometer per hour is the velocity of car A. And what about B? So if you find out the slope for car B, so I think this is difficult to read. Let us see over here at this point. So the slope will be this upon this, right? This is 80 upon 2. This horizontal is 2. And this vertical is, this one is 80. And this, see, this distance, 80 minus 40. Okay. So 80 minus 40 upon 2. That gives you 20 kilometers per hour. Right. Then the third one, the time in which the car A catches the car B. So at this point, the car A catches the car B, right? What was the time at this point? 2 hours. So at 2 hours, it catches car B. Then the fourth question, the distance from start when the car A will catch car B. So at this point, what was the distance at this point? 80 kilometers. So at 80 kilometers, the car A will be catching car B, right? So this is how you have to do. Then a body at rest is made to fall from the top of a tower. Its displacement at different instances given in the following table. Draw a displacement time graph and state whether the motion is uniform or non-uniform. So for this you have to draw scales like this, like they have drawn, and in this way you have to mark the points, point 1, point 2, point 3 and so on, and then mark the displacement over there. This you can do by yourself. Then figure 2.41a shows the velocity time graph for the motion of a body. Use it to find the displacement of the body at these instants. Then draw the displacement time graph. So at 1 second, what was the displacement? How do you find the displacement from velocity time graph? By finding the area of below the slope. Okay, so at 1 second, the area is area of this triangle, right? So half base into height. Base was 1, height was also 1. So 0.5. Okay, this comes out to be 0.5. and then at 2 seconds, 2, see, so you'll find out again half multiplied by 2 and 2, right? So in this way you'll get different points and you will mark over here. So okay, let me find out one more for y'all. So next one at 2 is 1 by 2 into at 2 into 2 into 2. So this will get cancelled out, so 2. So at 2 it is 1, I'm sorry, at 2 it is 2, and at 1 it is 0.5. So 0.5, see the middle point over here will be 1 and below that will be 0.5. So in this way you will be getting the points, and so you will plot the points, and I think it will be a curve kind of structure. I think so, I don't know exactly, you'll have to plot it and then find out. I just told you how to plot the graph, right? So okay, come to the ninth one. Figure 2.42. This one gives a velocity time graph for a car starting from rest. The graph has 3 parts, A, B, B, C, C, D. State how is the distance traveled in any part determined from this graph. Distance traveled by obtaining the area. Compare the distance traveled in part BC with the distance traveled in part AB. The part BC, you find out the area of this. Distance traveled in AB, find out the area of this, and find out the area and compare them. Okay, which part of the graph shows motion with uniform velocity, uniform acceleration, uniform retardation? So see here, this part shows uniform acceleration because the slope is uniform, no? The uniform acceleration. Here there is, the slope will be 0, so no acceleration, that means velocity is constant. Can you see here the velocity from B to C? At B is also V0, C also V0. Straight line. I told you earlier that a straight line, horizontal line parallel to x-axis, shows constant whatever is on y-axis. If it is displacement, this line will be showing constant displacement. If this is velocity, this is showing constant velocity, right? And then constant retardation. Here you can see it is retarding. Velocity is decreasing from a higher value to 0. So this one is showing constant retardation. So in this way you have to do the questions. So please try doing these questions by yourself. And for these I'm not giving you the solutions. I've discussed almost 9 questions over here, and 10th, 11th and 12th I'm leaving for y'all. So in exercise second C I have solved all of them, and some questions I'll be discussing.